Before we show you the technique for our video, we're going to discuss some of the important background information and concepts for this lab. The first thing we're going to do is discuss what a meniscus is. A meniscus is the convex or concave surface that is at the top of a column of a liquid. A meniscus occurs because of the polar nature of water and glass. This polarity causes the water to attract to the glass and stick to the sides of the glass and to form a meniscus. Here is an example of a meniscus in our graduated pipette. All volume measurements have to be read from the bottom of the meniscus. In this particular example, the volume would be 6.20 milliliters. Next, we have the definition of what a stock solution is. A stock solution is a solution with a certain constant concentration. A dilution is when you use a stock solution and add another solution, such as water, to create a new solution of lower concentration. The formula we will use to relate the stock solution to the dilution is C1 times V1 equals C2 times V2. C1 is the original concentration of the stock solution, in this case 20%. V1 is the initial volume that we obtain of the stock solution. C2 is the concentration we will obtain from diluting the 20% stock solution with water. This is what we're solving for. V2 is the final volume after the dilution is performed, and it will be 25.00 milliliters for all four of the dilutions. In this experiment, our stock solution is the 20% sugar solution, and we are performing a dilution with water to get different solutions with less than 20% sugar concentration. First, we have to pour the 20% stock solution into a beaker. We poured some water into a beaker, and we're going to use this water to dilute the stock solution. We obtain the mass of an empty 25 milliliter volumetric flask. We need this so we can find the mass of the diluted solution later. We used a graduated pipette to get a volume of the stock solution, and then we read the volume on the pipette. The volume was 6.20 milliliters. We then transferred some of the stock solution from the pipette into the 25 ml flask. We read the volume of the pipette after we transferred some of the solution into the flask, and we got 8.49 milliliters. We diluted the solution in the flask by adding water with a transfer pipette. We added water until the meniscus reached the 25 ml mark on the flask. Finally, we took the mass of the flask with the diluted solution in it. The notebook shows the data for the dilution we performed in this video. This was our first dilution we performed, and we labeled it as sample 1. The notebook shows how we obtained the mass and volume for the solution. We manipulated the dilution equation to get the C2 value, which is the concentration for our dilution of sample 1. We also divided the mass by the volume to find the density for this sample. We had to repeat all of the steps shown in the technique part of this video 3 times to perform dilutions for 3 more samples. Here you can see how each of our group members used the pipette to obtain stock solution and transfer it to the flask. Each member made sure to record the initial and final volume of the stock solution. Then, the flask was diluted with water, and the rest of the steps that were performed in the first dilution were repeated for each of the next 3 dilutions.